Next illustration, there is a three-phase transmission line and the conductors are arranged in a triangular formation so that the two of the distances between conductors are 25 and the third is 42 feet. Okay, so from this you can now try to imagine what configuration are we taking in. So since sabi niya triangular and then 25, 25, 42, so more or less, it's not more or less, it's actually three-phase with unequal phase spacing, diba? Okay, so from there, we know now what equation or formula to use. The conductors are ACSR Osprey. So we just have to determine the capacitive reactance to neutral. Okay, so take note of that, to neutral, in ohm mile. Okay, again, in ohm mile. So the default is meter. Okay, so ohm meter. So we need mile. If the line is 150 miles long, find the capacitive reactance to neutral. Okay. Okay, so again, this is three-phase unequal phase spacing. So we are actually after getting the EQ muna, no? Diba? Okay. So our Cn here is simply 2 pi E ln of the EQ over R. Again, take note, farad per meter. So our configuration is something like this. Okay, so it's unequal phase spacing. So our equivalent D or the GMD is the cube root of 25, 25, 42. And our R is missing, but we can find it by locating that from the table. So we get the Osprey's outside diameter. Okay, that's 0.879 inch. Okay, and then since diameter siya, we need the radius. So divide lang natin yon and then yung conversion. Okay, so plug them in. Okay, so that's the radius, no? And then multiplied all those things by 1609 because again, the default is farad per meter, but we will be asking for miles kasi, no? So the conversion from meter to mile. So our Cn is now 0.01336 microfarad per mile. Okay, so the reactance will be 1 over omega C. So it will now be 0.1986 times 10 to the 6 ohm mile. Okay, kasi diba farad per mile. Tapos, XC is 1 all over omega C. So, yung C mo nasa denominator. So, tataas ngayon yung mile. Okay? So, that's our XC. Okay? For 150 miles of transmission length, okay? So, simply, what to do? Your Cn is multiplied to 150. Okay? And then, your XC will be divided by 150. Okay? So we'll get XC as 1,324 ohms. Okay, so as I check the problem statement, we don't need Cn pala for 150 miles, no? Yung considering the length, no? Hindi naman pala kailangan. But instead, yung capacitive reactance to neutral na lang pala. So that's XC, considering the 150 miles length. Okay? So please don't be confused, no? Yung Cn here in this case, no? Although not needed or although not asked in the statement, no? Your Cn here is multiplied to 150 because it's microfarad per mile times 150 miles. So you get microfarad. Now, in XC kasi, it's mile. So, you have to divide 150 miles from the XC para mag-cancel yung miles. And then, what is left is now ohm. Okay? So, please don't get confused of that. Okay? So, that's for illustration 3. Let us now try to have illustration 4. Okay? So, you might want to read the illustration, the problem statement. Okay? So, what do you identify now to use? So, there is this bundled conductor. Okay? So, again, may ACS are given details, which is 1,113 kcm kc mil conductor per bundle. So, the spacing between the bundle and of course between the conductors are also given. Now we have to get the capacitance to neutral and the admittance to neutral. Okay? So let us now have these equations be applied, to get the parameters we need. So nakabundle siya since that's 3-phase. Okay, tapos sabi niya there is this 3 conductors per bundle. So 3 conductors per bundle. Actually, if we'll have to go back to the problem, walang sinabi if it's triangular. The bundle itself, yung bundle. Pero we assumed that the bundle is triangular. Would that be always the case? Or pwede ring bundle na 1, 2, like horizontal configuration. Like for conductor 1, naka-bundle siya horizontal. Tapos bundle 2, naka-horizontal din. It can be the case, but in this case, you have to read between the lines. Sabi niya ay 3 conductors per bundle with 0.5 meters between conductors in the bundle. Between conductors. So, meaning, if, say, horizontal siya, yan, bundle 1, bundle 2, bundle 3, with 0.5 meter between conductors. Yan. Paano to? Diba? How would you describe these 0.5 meters between conductors? Okay? Unless sinabi niyang 0.5 meters between adjacent conductors. Ito yung horizontal. But, since sabi niya, between conductors, walang sinabing adjacent. So, the most appropriate configuration of the bundle is this 3 conductor bundle here in triangular formation, no? And actually, in our derivation for inductance, no, yung 3 conductor bundle natin is naka-assume to be like that, no? That's the configuration. So, do you think the DSC for a 3 conductor bundle, if ever, no, if it will be like this, magbabago? What do you think? Okay, you might want to find out, diba? Okay, so let's go back. So, we now have this 10 meters between the bundle centers and 0.5 in each conductor bundle. Okay, so Cn will be 2 pi e over ln of dEq over dsc. Okay, now again we get dEq muna, so the cube root of those product of distances, and then our dsc is since this is a 3 conductor bundle, so we have now cube root of rd squared. Okay, so where do we get r now? Kasi the D is already given. Again, from the table. So, the Finch conductor as described here, yung ACSR, and then you get to locate 1,113 kilo circular meal. So, pag nakita na yon, siguro there is a table there siguro na parang dalawa yung 1113. Ano? Meron naman dyan, if ever, no? Meron dyang isang table yata na parang very particular lang yung, specific lang sa Finch, yung 1,113 kc meal, no? So, if in case the table listing, okay, have the same kc meal, so magmamatter yung stranding and layering, no? So, since it's not given here in the problem statement, so there's another table there na specific lang yung 113 kay Finch. So, we'll take that, no, as the outside diameter. Okay? But at any rate, if there are conductors which have the same areas or yung kc meal, okay, cross-sectional areas, so the number of stranding, layering will matter. Okay? So in this case, we get the Finch outside diameter and then divide by 2 para we can have the R. Okay? And also converted to meter because our conductor spacing, no, between the bundles, no, is in meters, diba? 0.5 meters. So we have to convert that to meter now. And then plugging in all those, so we have 1.293 and then 0.0254/2. Okay, that's for our R. That D squared will be 0.5 squared, and then the cube root of that will give us a value, no? For the meantime, I will just have to store it in the calculator para later less rounding off. Next, Cn is now 2 pi e. So what do we have now is plug in all those. Okay, and then we get the capacitance to neutral in farad per meter. Okay, what else? We need the admittance to neutral. Okay, so admittance will be coming from omega times C, capacitance. Okay, so assumption 60 Hertz line, and then your C in farad per meter, because we are asked for the admittance in per kilometer. Okay, so that's why we have 1,000 here. Okay, so the admittance is now given as the value like this. Okay, so I think that's for illustration 4.